Here we go. All right, so we are recording. I got Zoom up, and let me let the person online in. There we go. All right, so we are gonna get started. The recorder is on already, and we are just gonna take a look at this exam, but only for the question, the G function or Aleph No related question. So I think I downloaded that already. Might not have clicked. There we go. Okay, all right. So the last question is the only one that we are trying to tackle today. There we go. All right. Um, I did not have time to put this onto my tablet, so I'm just going to answer the question here with the PDF. All right, so we are going to read the question carefully. The G function in the Aleph No module is a function G. It, the Cartesian product of n, that's the domain. It maps to just the set of natural numbers. Define a function f that maps from integers to natural number that is bijective so that you can combine the use of g and f to make a function h so that h has a domain of the Cartesian product of integer to natural number. So so I give you the actual definition of h. H of xy as a two tuple is going to be the g of f of x, f of y, and then that forms a two tuple. So do we have any questions up to reading to this part? Okay, define your function f in the following space. Okay, so all right, all right. So first question is, how do we define f? What is the quickest way to define this particular f? Yes, yes. So the quickest way is to copy and paste it from my definition of f that serves exactly the same purpose in the Aleph No module. Okay, so do you guys know which function we are talking about? The general idea is you fold negative numbers to odd natural numbers, and then you extend non-negative integers to even natural numbers. Okay, that's the best way I can describe it. Okay, so does that ring a bell? If it does not ring a bell, you might need to read that module again. Is that a fair answer? Okay, so let me at least point out which module you need to read to get those particular items. And that is under after functions in Aleph No. There's only one single reading module in Aleph No. This is the module that you need to read. Okay, so I will even go to the extent to finding f for you. Okay, so function f is staring at you in the face. Okay, so if you did not know where to find that function f, you might need to get a little bit more familiar with the reading material. And I believe that particular lecture was also recorded, which means you can also rewatch the entire thing if you wish. Are we good with that? Okay, cool. All right. All right, so given that we know what f function we are talking about, so the next question, let me switch back to the exam here. So you just kind of copy and paste, the definition of that function here, and I'll go ahead and do it. Okay, so let me use I'm just going to type today and instead of just handwrite. So we go to mouse pad. There we go. All right, so I'll put it like right about here. So f of x being an integer is if x is greater than or equal to 0, and move the clock a little bit up here, then we are talking about 2 times x. Otherwise, we are looking at -2 times x, and then the whole thing minus 1. There we go. Okay. All right. So that answers this part of the question, what f we are talking about. And then in the following space, I want to figure out what is h of -6 and -5. Well, the whole thing is already defined here. In other words, we're using the same g function in aleph null, the module, and then we just plug in the f that we have chosen to use in this case. So that means h of -6. Okay, let me h. Oops. Okay, h of -6, -5. -6, -5 is itself a two tuple because it is an element from the domain of H. Okay, so that's why there are double parentheses. It's not a typo. It is not redundant. Okay, the outermost parentheses, which is highlighted right now, is basically saying whatever is inside are parameters. The inner pair of parentheses is saying the parameter itself is a two tuple with -6 as the first item of the two tuple and -5 as the second item of the two tuple. So there's no redundancy here. There's no syntax error here. Every single symbol is required. All right. So now we use the definition, okay? We just expand it. It is the g of, okay? And the g function also applies to a two tuple, and that's why we have quote unquote double parentheses. Once again, they're both necessary. And then based on the definition that we saw here, which is given to you, so now we have to apply f to the first item of the original two tuple. So we have f of -6 here, and then we have f of -5 here. So is that okay? I'm just doing a step-by-step expansion of how H is defined, and then I can also do a step-by-step evaluation. So I first have to figure out what is f of -6. Okay, -6, is it greater than or equal to 0? Nope. So what is -2 times -6? It is -12. -12 minus 1 is 11. So we'll put 11 here. Huh? Oh, okay. It's just 12 because -2 times -6 is just 12. Sorry, I misspoke. And then the other one is 9 because -2 times -5 is 10. 10 minus 1 is 9. So now we just have to figure out what is the g value of the two tuple of 11, 9. And now you have to look up what is the g function. So the g function is described in the aleph null module. Yep. Yep. Yep, there's only one g function in the entire aleph null module. And the question did say very specifically, we're looking at the g function of the aleph null module. Yep, okay, so now we just say, okay, this is 11 plus 9 times 11 plus 9 plus 1, the whole thing divided by 2 plus 9, because 9 is the quote-unquote y coordinate. So you just get your calculator out, do the calculation, or if you're good at mental math, you can also do that too. So this boils down to 10 times 21, which is 210, plus 9, which is 209, if my math is correct. Is that correct? Okay, excellent. So that answers the second part. So that's just a warm up, okay? Because up to this point, it is all about knowledge, okay? Basically, did you read the notes, okay? Did you know what is the function f? Did you know, how function g is defined? That's all, okay? You're up to this point. So just for the knowledge alone, people can get up to half the points already. Okay, so the other half is about problem solving. Okay, it's about, okay, how do we apply the knowledge in this case? So this is the third part, because G and F are both bijective, because both are described in the aleph null module as being bijective, okay? Because F was used to show that the set of integers also has a cardinality of aleph null. G, on the other hand, was used to show that the Cartesian product of natural number and natural number is also, it also has a cardinality of olive null. So both of those are known to be bijective because of the module. So that's why, there's the claim as, that G and F are both bijective. We know that H is bijective, okay? Because if you make a compound function of bijection, the bijections, then the compound function itself is also bound to be bijective. So no need to prove this part of your answer. So you don't have to prove that H is bijective. I'm telling you that it is bijective already. But what I'm interested in is using G inverse and F inverse. I want you to define H inverse. Okay, so now the question is, how do I define H inverse? So the xy as a two-tuple is the inverse of H applied to some integer v. Okay, so that's basically what the question is asking. So first of all, I just want to check, does everybody know what the question is asking? Okay, it even tells you what the xy are integers and v is a natural number. So do we have any questions about parsing the question itself? Do we know what the question is asking? Okay, so this one is not asking about a specific application like, oh, okay, these are the numbers that we want to work with. This is asking you about the structure of H inverse. Okay, so the way we answer that question is to say, all right, so we know H inverse, okay, okay, I might still need to use my tablet. Okay, fine, it won't take long. Give me a second. All right, so just need to get to Supernote here, refresh. Okay, it doesn't like it when I have another, oh, wait, it just showed up. There we go. All right, cool. Need to get my tablet, stylus. Okay, there we go. All right, so we know that H is defined to be the G, H of xy is defined to be the G function applied to f of x, f of y, put it into a two-tuple, and then apply G to the two-tuple. So that much we know already. And now we look at the H inverse of V, and V is an element of the natural numbers, okay? So what is the format of this thing? What is H inverse of V going to give us? Okay, so look at it from the other perspective, okay? The other perspective is H is a function that maps from the Cartesian product of integers to natural numbers. Yep, it maps backwards, right? That's all it does. So H inverse is going to map exactly in the backward way. It maps natural numbers to the Cartesian product of integers Cartesian cross with integers. Is that okay? So that would give you an idea of, oh, okay, so the H inverse of V is going to give us, a two-tuple, okay? So we'll just call this one U, and we'll call this V. Is that okay? Because I need to refer to each one of those members to do something about it. Okay, so now you look at U, okay, and then you ask, what exactly is U? It is an integer, okay, which means, oh, we need to map it back into no, I take it back. I take it, yes, we have to map it back into a natural number. Okay, because what is F? F maps from the set of integers to the set of natural numbers. So F inverse is going to do exactly the opposite. It maps from natural number back to the set of integers. So U is actually U is supposed to be an integer. but we need a step in between because we need to use G inverse, okay? So now we look at G inverse. G inverse of um, and I want to give it a number, let's say lowercase n. So this will give us a two tuple, and a two tuple, instead of calling it u and v, we'll call that x and y. So we have all of these pieces. The question is, how do we apply these particular thing? So the question is also, if you have a compound function, how many people know what is a compound function? Because you have all taken pre-calc. So I think they talk about a compound function in pre-calc, do they? Okay. So when you have a compound function, okay, so let's say you have g applied to f, okay, and this is of x. How do you find the inverse of this thing here? So we'll call, okay, let me, g applied to f applied to x, we'll call this y. So how do we reverse y back to x? Yep. Well, you apply inverse functions, right? So the way you do it, yes, go ahead. So the way we do it is algebra. Do you guys agree that the second equality should hold? In other words, I look at g of f of x, which is y, okay? And then I just apply g inverse to both sides of the equality. So that should maintain the equality, right? But at the same time, it's going to g inverse is going to undo g itself. So that means, if I look at this, okay, I'm apologize for the messiness of this thing. So now we have f of x equals to g inverse of y. Does that make sense? Because I just cleaned up here, because the whole purpose of an inverse function is to undo the function. Okay, so when you have a successive application of the inverse of a function right after the function itself, it just cancels out as if nothing happens. Okay, so now we can apply the same thing again. Now we apply the f inverse to f of x, and on the other side we applied f inverse to the g inverse of y. Okay, and this f inverse and this f here cancel out. So now we have x being f inverse applied to g inverse of y. Is that okay? So how we apply this to our question is we just look at the ordering of the application of the functions. So whatever operation was applied last, you have to apply the inverse first. So when you look at how g is applied last, so that means we have to apply g inverse first to v. So we have to apply g inverse to v, which will then give us xy. But x itself is after the application of f. So now we have to reverse that. So now you have to apply. So you say basically u is f inverse of x, and then v is f inverse of y. Yep. Say that one more time. Um, are you talking about the on the right hand side or talking about the left hand side? Huh? You mean this part here? Oh, this part? How does, what was the question again? Yes. Because when we computed h of xy, we applied g last. So when we look at the inverse, we have to reverse the effect of G first, so that we end up with the two natural numbers, and then the two natural numbers that we end up with, which are x and y, they each one need to be reversed back into integers, and that's why we have f inverse applied to x and y. Is that okay? Well, let's apply that. Okay, so we'll do a sanity check by applying that to the numbers that we have been working with. Yes, go ahead. Can you ask the question again? None of the above? You're gonna have your own? And I have not decided yet what kind of question you're gonna get. Yes. Mm-hmm. G was the last thing to apply, right? And as a result, when we look at the inverse function, it will be the first thing that we have to undo. No, you give me so the ultimate thing that H is doing is you give me x, y, which are integers, and I'll give you a natural number corresponding to the two tuple where each item is an integer. That's what H does, which is described by this statement here. So when we reverse, we want to go from a natural number back to the two tuple of integers that corresponds to the natural number. That's ultimately what we want to do. But there's a step in between, because in order to accomplish function h, we are using g and f like this. So that means when we get the result after the application of h and we want to do the reverse, the first thing we have to reverse is to reverse the operation of g, so that we are going from a natural number back to a two tuple of natural numbers. And then for each item of the two tuple of the natural number, we reverse that back to the integer that the natural number is representing. Yep. Sorry? The tiles that we did? That's what G does. So we want to reverse that. Okay. So we want to reverse that. Yep. Yeah. No, each one. Because F inverse is only mapping from the set of integers to the set of natural numbers. So when you reverse, you can only reverse one natural number to the corresponding integer. So you have to apply F inverse twice. How do I what? I'm not sure what you mean by equalize. Mm, they become two different equations. So U is the result of F inverse applied to X. V is F inverse applied to Y. And ultimately, when we apply H inverse to V, we end up with, oh, I guess I should not be using V again. Okay, so we have to use a different one, say W. So sorry about that. That's my bad, using the same variable twice. Does that make more sense? Okay, yes. It will not compile. Yes. Yep. Plug that back. Yep. Yep. All right. So the best way to illustrate it is to plug in actual numbers, right? Okay. So we already worked out a few actual numbers, in the mouse pad here. So you can look at this, and then I'll just copy stuff, right? So I would say, so we have to apply H inverse. I'm just looking at the mess here. Okay, we'll carve out a little area here. Okay, so now we want to apply H inverse to 219. And we want to figure out what that is. Okay, so ultimately, there should be an integer here, and there should be another integer here, because H itself is taking a two tuple of two integers and map it to a natural number. So H inverse should take a natural number and reverse it back into a two tuple of integers. Does that make sense? So ideally speaking, if I apply this function, ultimately I should end up with 11, 9 as a two tuple. Yes. No, that's not what H does, because H has to ultimately it uses G, but for the original XY, you have to apply F to X, and then you have to apply F to Y first, because X, Y are integers. G does not work with integers. G only works for natural numbers. So you have to first convert X, Y from integers to natural numbers. Then you can apply G, because G works with two tuples of natural numbers. And that's what we did with the forward moving part is here. That's what we did. But the question I'm trying to answer is, how do we reverse the process? I claim that I know how to reverse it already, but I need to show that it works for at least for the example that we have been working on. Yes. Look at this. You apply H to a two tuple of integers, we end up with a natural number. H inverse should do the reverse. We applied H inverse to 219, we should get -6 and -5 back. Exactly. Parentheses, yeah. Because that's what H inverse does. It takes a natural number, convert it into a two tuple of integers. Okay. Yep. But the question did not ask you to rewrite G. That's not what you were asked. But that's irrelevant to the discussion of the answer to the question as it is. So I don't want to use time for that. Is that okay? Because otherwise we'll run out of time. There are many other ways to do the same thing, but the question is, the thing I want to go over is, how do we answer the question as it is? The test did not ask you to rewrite G. If you rewrite G, then it would be the wrong answer. So you have to follow the instructions, because your G would not be consistent with the G as described in the Aleph No module. And as a result, it would not be considered as the correct answer, at least not 100%. Let me finish this first, okay? Let me just finish this first, and then we'll talk about potentially what other things can we do, okay? Because otherwise we're always halfway through finishing this whole thing, and then we'll never get to the end. Okay, so now we ask this question. So we apply G inverse first to 219. So G inverse is a beast. Okay, so if you have a programmable calculator, you can probably just program in the W inverse, or the W function to make your uh, life a little bit easier. So what I mean by that is you go to this module and then you look for um, the inverse of G, because the inverse of G requires you to compute W of n to begin with. So this is W of n. So we're going to do this calculation. So now the question is, what is W? W of 219. I'm writing it on the tablet. I will switch back in just a moment. So that would be the root of 8 times 219, the whole thing plus 1, take the square root, minus 1, and then the whole thing divided by 2. Okay, so let's try to figure that out. Oh, it's in a different tab. There we go. All right. So this is what we are trying to calculate, this part here. We want to figure out W first. So if you have a calculator, okay, I'm just going to cheat with a calculator. You are allowed to bring a calculator, okay, even a graphing one, okay, which is more fancy than you actually need, but it doesn't hurt. So we have 8, sorry. So 8 times 219, the whole thing plus 1, take the square root, the whole thing, subtract 1, and then divide 2. So that's 20.43, but because we are only using the floor of this thing, okay, so I forgot that there's a floor here. So what was it again? It was 20, okay? So W of 219 is 20. So now the question is, how do we get from this to the respective inverse of G inversed? So G inversed, okay, so we go back to the slide again. So this part is just knowledge, okay, because it's already given to you. How do we compute the X of G inversed? So we are looking at 20 times 23, the whole thing divided by 2. I'll do this part on the whiteboard just because I'm out of real estate on the monitor. So we're looking at 20 times 23, the whole thing divided by 2, minus n, which is minus 20. So that's x. So what is it? 10 times 2. So this is 230 minus 20. 210. Okay. So 210. No, that doesn't make sense. I have to be making some mistake somewhere. Just doesn't seem like it should be the case. Oh, it's n. Okay. I plugged in W instead of n. This is not the correct answer because we're looking at n, and n is 219. There we go. Okay, now it makes more sense. Okay. Because I was looking at this and go like, no, that doesn't make sense. 230 minus 219 is 11. Okay. So that means we got 11 here, right? So we look at the other side. What do we get? We have 20 times 21, the whole thing divided by 2. And this time we want to subtract this from 219. So we are subtracting basically 210 from 219, and we got our 9 back. Well, do those numbers look familiar to you? I hope so, right? Okay. So getting back to the tablet, okay, because we are tracking the answer on the tablet here. So that means the G inversed, okay, is giving us 11 and 9 here. Is that okay? But we are not done yet because the 11 and 9 are natural numbers. We need to map the natural number back to the integers that they belong to, that they represent. Yes, go ahead. Okay, yeah, we can talk about that maybe after class. So now we need to figure out what goes here and what goes here. So we apply F inverse to 11. That goes here. We apply F inverse to 9, and that goes here. So what is F inverse of 11? Well, Tech, you never talked about the inverse of F. Yes, I did many weeks ago, and it is in the module. So that means, oh, okay. So that means if I just read the module and look for F inverse, I can just use that. Okay, well, where's F inverse? Right here. Okay, so now we look at F inverse and we apply this to 11. So X is 11. 11 mod 2 equals to 0 is false. So we go to here. 11 plus 1 is 12. 12 divided by -2 is -6. Okay, cool. So that means in my slide here, the -6 goes here. And now I have to reapply the same function, but to, what was it? 9, okay? So F inverse of 9 is, based on the ternary expression again, 9 mod 2 equals to 0 is false again. 9 plus 1 is 10. 10 divided by -2 is -5. So that -5 goes to the second item of the two tuple that I was filling in. So the -5 goes here, and voila. So I have, this is not the proof, okay? This is not a proof that the structure of H inverse by using G inverse and F inverse is correct, but it is an example of how it can be applied. Is that okay? Yep. Mm-hmm. Mm-hmm. We start out with, there are quite a few functions. You have to be a little more specific. All right, let's read the question. I say that because I really do not remember what the question asks. Okay, so it starts out with the G function in the Aleph no module is a function, blah, blah, blah. So it describes what that function is. It is a function, it uses the Cartesian product of natural numbers as the domain, and it maps it to the set of natural numbers. Okay, it's just a description of what it is. Define the function f so that it is bijective. And I need function f to map from integers to natural numbers. And I need it to be bijective. You guys go like, wait, I think Tech gave us a function f that does exactly that. Yes, that was the whole purpose. Okay, I want you to use whatever is already given to you. So now you go like, oh, okay, copy and paste function f here, done. And that's what, 20% already. Okay, then what do we do? And then we say, okay, so now that you know what function f is and function g is in the Aleph now module, so we just have to say, oh, Tech wants me to evaluate what is the h function applied to the two tuple of -6, -5. All right, well, this is what we want to compute. Take -6, plug it here, take -5 and plug it here. When I said here, it is f of x, the x of f of x, and then the y of the f of y above. Okay, because I have to describe to the person who's online who cannot see where my fingers are. Okay, so this -6 goes here, this -5 goes here. So we just have to apply f twice. Okay, once to -6, once to -5, it comes back with two natural numbers, and then we use those two natural numbers, apply G, done. And that's how we got 219 as an answer. Okay, so part 3 is going, is probably the most difficult part, is given how H is defined using G and F and both are bijective, how do we figure out the inverse of H? If I give you a natural number, how do I know which two, what is the integer two tuple that it corresponds to? That's the question. Okay, so that has to do with when you reverse a compound function, the inverse is the reverse order of the inverses of the constituent functions. Okay, I think I said it out right, correctly, but did you guys understand what I just said? Okay, so I'll write it on a clean piece of paper, so this time it's not as confusing. Okay, so the G, F, and H in this case has nothing to do with the question. Okay, this is just in general. So if I define H to be G after F, then H inversed is F inversed after G. Hmm? Oh, great. There we go. Thank you. So that means the order of undoing is exactly the opposite of the order of how things were done in the first place, which is also how your spreadsheet and your word processor gets the undo done. Does that make sense? Okay, you guys are not, some of you do not seem to be believing what I said. So let me first charge my tablet first. It says 20% left here, which is plenty, but I am not going to risk it. So there we go. Okay. All right, so I think this part is going to be a little bit easier to remember. Okay, this is in, okay, let me go to the, I don't think I need to put this into the shared folder, but I'll put it here anyway. Okay, just as an illustration. So I'm going to create a Google Doc, and I'll just call it do and undo. All right, so what I'm going to do here is this is a sentence. Okay, so what I'll do is I am going to underline the entire thing, and then I'm going to boldface sentence. All right. If I type Control Z right now, what's going to happen? Is it going to get rid of the underline of the entire sentence, or is it going to get rid of the boldface of sentence itself? Exactly. And then if I undo one more time, what is it going to do? The underline. That's exactly what I'm trying to say. Yep. I do not know. But that part is irrelevant to the current discussion also. Yes. Is that okay? Does that kind of help you understand what is the application of a function? But when you undo, you reverse the order of how you did things in the first place. Is that okay? So given that is the case, so that means when okay, so that means when H is the result of applying F first to the individual XY, and then perform the G on top of that, the undoing will have to start with undoing G first. And that's why we have to look into G inverse first to V. And G inverse will give us two natural numbers, because that's what G inverse does, is to give us two natural numbers. Each of the natural number is the result of applying F. So that's why we have to apply inverse F inverse to X in order to get U. And then we have to apply F inverse of Y to get W back. So does that help explain the whole process of the third step of the question? Yep. Mm-hmm. All right. So I do not know how to help with that portion, because that is probably reading comprehension. Um, yes. Mm-hmm. Mm-hmm. it's like a stack, right? So when you push two items, the first item that you the first item that you pop is the last item that you push. So it's the same thing. It's a LIFO. It's a last in, first out order. Exactly. Yep. Hmm. All right. So that's kind of the whole explanation of this. One thing I really haven't tried, but probably worth trying, is to upload the entire LFNO module to ChatGPT and then upload the question itself to ChatGPT and see if it can give you some idea of how to solve the problem. Do you guys want to do it? Say yes. Just say yes. Okay, let's do it. All right, so we'll do just that. But before that, there was a hand. I want to answer that question first. Go ahead. Okay, say that one more time. You have to speak up a little bit. Because the G itself, because the G itself is applied after we figure out what is f of x and f of y. So the undo of G is going to only give us f of x and f of y. I don't really care that much about f of x and f of y. I want to know what is x and what is y. And that's why we have to reverse whatever f of x is back into x by applying f inverse to f of x. Huh? So f inverse of this x here is the u which goes here, which ultimately is the same thing as this x over here. So I basically use the variable names in a kind of mixed way. You mean here? So these f and g have nothing to do with the f and g here. I'm just using those as generic function names. Say again? No, the x is not found. X is copied directly from the module itself. So the f in the question is the one from the module itself. The f on the right-hand side here is just a generic function because I just want to illustrate, why does it make sense to reverse a compound function in the opposite order when we want to apply the inverse functions. One is a generic, yeah, from here, this part here, all the way up to here, that portion is generic. That's just showing you when we apply inverse function, you have to apply that in a reverse order. In other words, all you have to do is to look at this thing here and look at this thing here and see how they're opposite. Yep. Mm-hmm. Well, yes, but in a special way because they're it when if we're dealing with functions that only has a single value and it maps to a single value, easy to represent. But in this case, we have a G function that takes a two tuple and turn it into a single value. And there's not a whole lot of notation that I can use to explain that. And that's why I have to first apply G inverse and say, okay, it's giving us this particular two tuple where we have I use a variable to represent the first item of the two tuple and the second variable to represent the second item of the two tuple. Then I can talk about what do we do with each one of those items that are the result of G inverse. And then we have to apply F inverse to each one of those in order to get all the way back to a two tuple of integers and not a two tuple of natural numbers. Yep. Yes, I did. It is in the announcement and an example of a G function question. Yep. Okay. All right. All right. So are we? Yes. Go ahead. Hmm? Yes. I have yet to decide what kind of format it will be in, but I can tell you this much. It requires you to understand what the G function is, most likely the inverse function, the concept of a function versus its inverse, and probably some kind of nesting of application of functions. Yep, that is correct. Aleph No is the last topic of our discussion included in the exam. Yep, that is correct. All right, so are we ready to kind of have a chat with Chat GPT? Okay. Well, this is fun. Okay, to me, this is fun. Okay, if you don't find out, if you don't don't think this is fun, okay, I don't know what to say. I don't know what to say. Okay, so here's the copy of the all the notes here, and then just start up a Chat GPT, Chat GPT. All right, so it's always helpful to upload the notes so that you can give the whole conversation a context of what F function are we talking about, what G function are we talking about, blah, 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 blah. So you have to give it the context. So you basically go like, okay, the following is the instruction material for a discussion of Aleph No, Aleph No, um, in discrete structure. I will ask additional questions in the following prompts. Okay, bad grammar because there's no the in this case in following prompts. Okay, somehow it's highlighting it red. I don't know why. So Control V, there we go. So now we uploaded everything, including all the exercise questions. Okay, and just scroll all the way to the bottom. Okay, there we go. That looks like a thorough instructional material on Aleph No. Well, thank you. Finally, finally, somebody says, that's a thorough, instructional material and countability. Okay, cool. So now I need to upload the question itself. The question itself, okay, I can even show you exactly how everything is done on this side. So I think this is from the spring semester last year. Okay, so I have to go to exams, CISP 440, 1243. Okay, and then we have to look at X1, and I think I maintained the MD file. Yes, I did. Okay, that's the last question. Okay, so we are looking at question 4. So we have to, okay. Okay, now this part is a little bit iffy because I cannot remember the syntax to pipe writing a section of a file to the clipboard. So, say again? Question 5? Oh, okay. Oh, that does not work. It just creates a file with that name. Okay. So I think instead of doing that, it is. Did I do a W exclamation point before? Or was it exclamation point W? W. Okay, well, fine. I'll do it the more conventional way. Just write it to a regular file and then we'll deal with it later. Okay, there we go. Xclip, cell clip, raw.md. There we go. All right, so now we get back to ChatGPT and go like, this is a question related to the uploaded material. Can you help me understand what it is asking and guide me um, to answer this question. Okay, and then paste again, Control V like that, enter. All right. Oh wait, oh, it doesn't like ternary expression. I'm sorry. All right. All right. So now we defined, we already, the question gives you the definition already, and we just need to do the actual calculation. Okay. So this is the actual calculation. Step by step. Okay. F applied to -6 is 11. F applied to -5 is 9. Okay. Very good. And then we apply G on top of that, and that gives us 219. Super step by step, right? Okay. And now we define X inverse. So this is the tricky part, right? So I have to read this part to make sure it is correct. So it says use G inverse to find AB from V. And then for each one of the AB, apply F inverse to find the X and the Y. So it is actually correct. Not bad. Okay. And now for the last one, given the actual example that we use, to verify this, right? So it says, first of all, we have to apply G inverse to the natural number to find A and B. And it even quotes the WN function that I have included in the module. It finds that W is 20, just like what we did on the whiteboard. And then it figures out that B is 9 and A is 11. So G inverse of 219 is 11, 9. And then we compute the F inverse applied to 11 and the F inverse applied to 9. And they are -6 and -5 respectively. And the answer is this. So I'm not sure what to say. Impressed is one. I think this can also be scary. It's not scary to me because I am within single digit years of retirement. So unfortunately, that is not true for most of you. Yes. You mean the proof of the inverse function? So the inverse function proof, is really in the structure. It has to do with the structure of how we apply the function and the inverse function. Yep. Sure. I don't see why not. I really don't see why not. I think this is a good way for you to at least understand what the current state of AI can do. By the time you graduate with a bachelor's degree, it'll be 2 years later. And according to Moore's law, everything will be twice as capable. The mass store, network speed, processing speed, everything will be doubled by the time you graduate. So, so I think there are a lot of questions you really have to ask yourselves. And I will try to help you answer some of those questions, but so who am I? I'm just a lowly professor teaching at a community college. So a PhD is nothing more than a piece of paper. It doesn't even keep me warm in the winter. Okay, most people say UC Davis, go Aggies. I go like, moo, moo. You're an Aggie. Moo. Hmm. All right, so this is, how should I title this thing? Chat GPT's answer to the olive no question. There we go. And off he goes. All right. So I think if not for anything else, so I know we are burning time right here. If not for anything else, okay, this entire conversation, especially the part that involves your ChatGPT, is significant because it shows that ChatGPT can understand the entire question. It knows what the question is asking, relate the question to the material that I just uploaded. Okay, it's not even using its background knowledge that has been trained on. It's really just looking at the text that I uploaded as the context and figure out the answer from within that context. Okay, so I think that is significant. The other thing that is also significant for people who look at the original question and go like, okay, how do I even get started answering this question? You can ask ChatGPT that too. Okay, so you can ask introspective questions to ChatGPT, such as, okay, um, explain how to answer this question, right? So explain how this question is answered with respect to the material that was uploaded earlier. In other words, explain the chain of reasoning and association, okay, or connection, whatever you want to call that, okay? Because what you want to know is how does ChatGPT read the question and say, oh, okay, according to this part of the question, I need to look that up in the module, okay? Because that's the first thing you need to do is to relate the question to the material that is presented to you. Okay, that you need to know that part before you can even apply reasoning. So there you go. So you can also, I mean, there are many, many ways to use ChatGPT or an AI in this particular context. Um, I'm not going to read the whole thing, but I can tell you one thing, okay? I can tell you that at some point, I won't be needed anymore because I can, okay, let me show you some secret stuff, okay, that most of you do not know about, okay? Okay, this is going to the inside website here, okay, so and this is the curriculum services. Go to courses and then go to CISP and then go to CISP 440. There we go. And this is the ARC curriculum for CISP 440, the class that you're in right now. So the whole thing has a bunch of learning objectives, which are fairly high-level descriptions of what you're supposed to learn, and then followed by a bunch of topics, okay, sets, uh, propositional logic, predicate logic, blah, 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 and so on. So at some point, I can probably copy and paste this to ChatGPT and say, ChatGPT, can you give me an outline of a 16-week semester and what I need to go over each week? And then I say, for each week, prepare the material that I need to talk about. And also prepare homework assignments for my students. Do you see where I'm going? To assess whether the students understand these concepts or not. Okay, so let's just say that you guys all get the homework assignments, and somebody is not getting a very good score out of the whole thing. So I can also instruct ChatGPT go like, okay, for each student, design a chain of additional questions, okay, to help students who are not getting a good score to remedy what is missing in that person's understanding of the material. I think that can all be done today, not 2 years later, not by the time you graduate. It can all be done today. Yes. I don't know what public schools do, so I cannot comment on that. Are you talking about Camigo from? Yeah. Okay. Hmm. Yeah. Yep. It can all be done. So that's so. What does it mean to you? I mean, some of you are probably feeling a little bored by now, and others, feeling go like, oh, this is kind of interesting. So What do you think? It's not about the second degree. You can still do, software engineering. Okay, I was talking about this with Iraj just a little bit ago, and I'll share with you once I answer this question. Hmm. Um, so most people use ChatGPT as a shortcut, but I'm not trying to use it as a shortcut. I'm trying to push it to see what it can and what it cannot do. So in other words, I'm trying to find the boundary of what it can do. Um, I'll show you this one more thing too. Okay, so if you are from FLC, you probably know this already, but if you're not, this is probably new to you. So if you go to, okay, you guys cannot see it, but I'm showing you. No, the AI classes. So where is it? I know they have an AI discipline now. There you go, AI. AI is now its own discipline, and at FLC, you can see all of these are Fs because they're all coming from FLC. Okay, so at FLC they have a certificate on AI, and they talk about all of these things. Well, I'm doing the same thing, except I sprinkle those things within my normal classes because I don't think they should be in a different class. I think they should be integrated into a normal class, quote unquote, normal class like this one, so that I can show you how it is applied. So that's kind of one of the things that I want to do because one, it is interesting to me. Two, I think it is super important for you guys to at least know what tech can do with ChatGPT, because I can tell you if I can do this with ChatGPT, other people will think of even better ways of using ChatGPT or any AI. Yep. Well, he can. Okay, he can. Okay, so um, yeah, but I don't want I don't want to use AI to write the text because I want to go through the whole process myself so that I understand the material that I'm teaching. What ChatGPT is really good for that I really suck at is making homework assignments. Giving you guys additional practice questions and stuff like that. I really am not good at that. Okay, but ChatGPT on the other hand is pretty good. So that's also a resource for you guys to practice. It's like, okay, I upload a module from Tech, and then I ask ChatGPT to give me some additional questions so that I can challenge my own understanding of the material. I can find out how well I'm understanding the material. Can I solve problems related to the material that we introduce in the classes, not just this one or any class? Yep. Maybe. Okay, so one thing I do want to talk about, which I just talked, I had a discussion earlier with my CISP 300 class. You can kind of imagine, you know, how they felt about this whole thing compared to how you feel about the whole thing, because you guys are about 2 years ahead of my CISP 300 students. So they're just starting out, right? It's their first class. So what I want to show is this is all relative, but this is just my opinion. Okay, you're definitely not proven in any way. So when you look at software development, okay, when you look at how systems are put together, in the good old days, you spend about maybe this much time on the why of the system that you're putting together. It can be a mobile app, it can be a entire information system, it can be a specific program, whatever. Okay, it doesn't matter. You spend a certain amount of time to ask, why do we need this? Okay, what is the value of this particular tool? And then you spend some time to talk about what it is. In other words, you look at the specification of the thing that you're trying to put together. Okay, so technically speaking, what is it supposed to do? What is the test that I can use to say whether the system is doing what it is supposed to do or not? Okay, and then you spend the rest of the time to figure out how to get it to how to put the program together. That's the actual coding part. Okay, so this was in the past. So today, with all the AI tool to generate to figure out the coding, the why is probably a little bit more important or take up a little bit more resources by comparison, just because you have to figure out, okay, what is the value of doing this? Because we have a lot of tools already. What is the value of this new tool that you're trying to put together? The what is going to take up a good chunk. Hmm? Well, it is. Uh, say that again. Scrum is not about that, right? Scrum is about the process. This is about how much time you spend on each portion, and then the actual how is smaller because you have AI assistants to help you to figure out some of the coding, not all, but some of the coding. So the question now is, what do you put here? How do you describe what the system is supposed to do? I'll just use words to describe the whole thing. Okay, what is the problem with using natural language to describe the specification of something that is highly technical? A prerequisite of knowledge, okay, but natural languages are intrinsically ambiguous, okay, ambiguous because it's never designed to convey something that needs precision. So what is by design precise? Yep, mathematics, math notations. Okay, so this really circles back to remember the example that I was using. How do you describe the proper outcome of an algorithm that sorts an array? Do you guys remember that? Do you remember how I used some really intuitive descriptions and I was able to how to describe that? I was able to uh, intentionally misinterpret the vague or the insufficient or imprecise description and go like, oh, this is my submission. Well, but tech, that's not a sorting algorithm, but it meets all the requirement. I deserve all the points, right? So it took us a long time to develop the vocabulary to describe what a sorting program is supposed to do, let alone what the program really is. We just want to describe what it is supposed to do. We need bijection to get that done. And to describe bijection, we need to talk about set concepts, you know, and before that, we have to describe all the logical operations. So you can kind of imagine, the what here, in order to describe something that is much more complicated, like encryption algorithms or network protocols and stuff like that, it's going to take a while, okay, to come up with the most precise way to describe it. And I think that's going to be the focus. I really think so. Okay, but once again, I'm just a community college professor teaching the very same class that I claim is important. So I might have a little bit of a conflict of interest here. And as such, you should always question my motive when I say something. So any feedback from you guys? We only got about 3 or 4 more minutes. Any feedback? This is a total waste of my time. I want my money back. Yes. Yes, it's a shift of what we do as software engineers. So instead of you know crazy coding with VS Code and whatnot, it'll be trying to figure out, what is it precisely that I want this program to do, or what this function is supposed to do, and so on. Yep. Yes, we are. Software engineers used to be just specify the specification of a system, not to do coding. Yep. I think the embedded systems, are can also be put together using AI, but it doesn't know as much because embedded systems are highly specialized. So one embedded system application can be very different from the next one. So I think the AI do not have sufficient training yet. And then plus all the real-time requirements, I don't think AI is quite sophisticated enough to make sure that those constraints are met. Yep. Yep. Okay. Well, thank you. Mm-hmm. Um, okay, I'll think about it. Mhm. Yeah, if you just watch all the YouTube from the past 12 years or so. But there's no advertisement. Okay, I did not ask YouTube to, I did not monetize my channel. But I think YouTube still you put advertisement into everything. Is that correct? Does it put advertisement inside the video? Like halfway through, it will give you, oh, okay, only at the beginning? Oh, okay, okay, gotcha. Yes, I don't monetize my channel. All right. Well, I'll see you guys next Monday. So study hard, and I still have office hours just in case. Mm-hmm. 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 Mm. Oh, I see what you mean. You can just send me, the like a screenshot. It usually has a code at the bottom that tells me which semester it is from, and then I can upload that. Yeah. Yep. Go ahead. Yes. You understand.